Welcome back to day 9. Here's a puzzle that confuses a lot of people. You hear that training a big AI model can cost millions of dollars and take weeks on giant computers. And yet, you can use that same model to answer a question in a fraction of a second, basically for free. How can the same AI be both wildly expensive and dirt cheap? The answer is that those are two completely different activities, training and inference. Today we'll pull them apart and then actually measure the gap between them with real code. It's bigger than you'd think. Let's dig in. So let's name the two phases clearly. The first is training. That's the process of building the model, teaching it by adjusting all those weights until it's good. The second is inference. That's simply using the finished model to make a prediction, building it versus using it. Here's an analogy that makes it stick. Training is like studying for an exam, months of slow, hard work. Inference is like sitting the exam and answering a question, quick and easy because you already did the studying. Same brain, two very different kinds of effort. Let's look at training first. Training is the heavy lifting. It means running that guess, check, and adjust loop across enormous amounts of data over and over, tuning millions or billions of weights. It is slow, sometimes hours, sometimes weeks. It is expensive, demanding racks of powerful, costly chips running full tilt. But, and this is the key, you generally only do it once, up front, to create the model. Almost all the eye-watering cost you hear about, the millions of dollars, lives right here, in this one-time training phase. It's the months of studying before the exam. Here's training in motion. The model starts out useless, just random weights, guessing at around 20%. Then it grinds. Pass after pass after pass over the data, slowly nudging its weights, and you watch its accuracy crawl upward as it learns. This is the part that eats time and money. Every one of these passes is a mountain of calculation, and big models do this for billions of examples. It's slow on purpose. The model is genuinely learning. But once that meter climbs up near the top and the training finishes, the hard, expensive work is done, forever. Now comes the fun, cheap part. Now meet inference. Once the model is trained, using it is a totally different story. Inference is just running your input through the finished network, one quick pass, and reading the answer. No learning, no adjusting weights, none of that grind. It's fast, an answer in milliseconds, and cheap, a tiny cost per prediction. And here's the beautiful asymmetry. You pay that big training cost just once, but then you can run inference millions, even billions, of times on that same model. Train once, infer forever. That's the whole economic trick behind modern AI. This is inference, and notice how different it feels from that slow training grind. An image comes in, an answer pops out, instantly. An email, spam, instantly. A question, an answer, instantly. Each one is a single quick pass through the already trained model, taking a tiny fraction of a second. The model isn't changing at all here. It's frozen, finished, just doing its job over and over. This is what's happening every single time you use an AI app. You're not training anything. You're running cheap, fast inference on a model somebody already paid to train. Let's measure just how different these two really are. Side by side, the split is crystal clear. Training is building the model. It's slow, taking anywhere from hours to weeks. It's very expensive, and you do it once, up front. Inference is using the model. It's fast, milliseconds. It's very cheap per use, and you do it over and over, millions of times. One is the costly construction project. The other is flipping on the light switch in the finished building. Keep this split in your head, and a lot of confusing AI economics suddenly makes sense. Now let's prove the gap is real. Talk is cheap, so let's put real numbers on this. We're going to take a neural network, and we'll use a stopwatch in the code. First, we'll time how long it takes to train the model from scratch. Then, we'll time how long it takes to make a single prediction with the finished model. Same model, two phases, measured. I think the size of the difference is going to surprise you. Let's look at the code. Here's the experiment. Up top, we wrap the training step, model.fit, in a stopwatch, recording exactly how long it takes to build the model. Then, down below, we time inference. We make 20,000 predictions in a loop and divide, to get a clean average time for a single prediction. Notice the two halves. The first builds the model once. The second just uses it many times. Exactly the two phases we've been talking about. Let's run it and read the numbers. And look at that gap. Training the model took about 2 seconds. That sounds quick, but remember, this is a tiny model on a tiny dataset. Scale it up, and that becomes hours or weeks. Now look at inference. A single prediction took about 0.17 milliseconds. That's less than a 5,000th of a second. Do the math, and using the model is roughly 12,000 times faster than training it. In the time it took to train once, you could have made 12,000 predictions. On a real, big model, that ratio explodes into the millions. That is the whole reason this matters. So here's the big idea to carry away. Train once, infer 1,000,000 times. The expensive, slow, painful part happens a single time when the model is built. After that, every use is fast and cheap. This is exactly why a company can spend millions training a model and then let you use it for pennies or even for free. The cost was front-loaded into training and then spread across billions of cheap inferences. Costly to build, cheap to run. And this split explains so much of the AI world. It's why training a frontier model can cost millions and requires gigantic data centers full of specialized chips, while serving that model to you is comparatively light and cheap. It's why your AI apps can feel almost free to use. The brutal cost already happened once somewhere else. And it's why companies obsess over making inference even faster and cheaper, because that's the part that runs billions of times. Once you see the training versus inference split, the economics of every AI product starts to click. Let's lock it in. Training is building the model. It's slow, expensive, and done once. Inference is using the model. It's fast, cheap, and done constantly. Train once, infer millions of times. And we proved it. The same model was thousands of times faster to use than to build. So the next time you hear that some AI cost a fortune, but you're using it for next to nothing, you'll know exactly why. Building AI is costly. Running it is cheap. So that's training versus inference, the slow, costly building of a model, and the fast, cheap use of it. And you watched a real stopwatch prove just how far apart they are. We keep mentioning these things called weights and parameters, the dials inside a model that training tunes. Tomorrow, we're going to zoom right in on them, what they actually are, why models have billions of them, and what that number really tells you. Thanks for building with me today. See you tomorrow on